Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Security Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
You are deploying a web application hosted on Compute Engine. A business requirement mandates that application logs are preserved for 12 years and data is kept within European boundaries. You want to implement a storage solution that minimizes overhead and is cost-effective. What should you do? The options are: Option A, create a cloud storage bucket to store your logs in the Europe West 1 region. Modify your application code to ship logs directly to your bucket for increased efficiency. Option B, configure your Compute Engine instances to use the Google Cloud's Operations Suite Cloud Logging Agent to send application logs to a custom log bucket in the Europe West 1 region with a custom retention of 12 years. Option C, use a pub/subtopic to forward your application logs to a cloud storage bucket in the Europe West 1 region. Option D, configure a custom retention policy of 12 years on your Google Cloud's Operations Suite log bucket in the Europe West 1 region.
To arrive at the correct answer, we focus on the keywords: preserved for 12 years, kept within European boundaries, minimizes overhead, cost-effective.
The correct answer is Option A, create a cloud storage bucket to store your logs in the Europe West 1 region. Modify your application code to ship logs directly to your bucket for increased efficiency.
Why is this correct? A. Cloud storage natively supports the required 12-year retention, whereas cloud logging buckets are limited to 3,650 days, 10 years. Deploying the bucket in Europe West 1 satisfies data boundary requirements. Why are the others incorrect? B. Cloud logging custom log buckets support a maximum retention period of 3,650 days, 10 years, making a 12-year retention configuration impossible. C. Introducing a pub/subtopic adds unnecessary architectural complexity and operational overhead, violating the requirement to minimize overhead and remain cost-effective. D. Cloud logging buckets have a strict maximum retention limit of 10 years, 3,650 days. A 12-year custom retention policy cannot be applied to a log bucket.
You manage your organization's Security Operations Center, SOC. You currently monitor and detect network traffic anomalies in your VPCs based on network logs. However, you want to explore your environment using network payloads and headers. Which Google Cloud product should you use? The options are: Option A, Cloud IDS. Option B, VPC Service Controls logs. Option C, VPC Flow logs. Option D, Google Cloud Armor. Option E, Packet Mirroring.
To arrive at the correct answer, we focus on the keywords: monitor and detect network traffic anomalies, network payloads, and headers.
The correct answer is Option A, Cloud IDS.
Why is this correct? A. Cloud IDS provides native, managed network threat detection. It inspects both network payloads and headers to identify intrusions, malware, and anomalies that cannot be detected using flow logs alone. Why are the others incorrect? B. VPC Service Controls logs record API request metadata for perimeter security to prevent data exfiltration, but they do not contain network packet payloads or headers. C. VPC flow logs only capture network flow telemetry, such as IP addresses, ports, and bytes transferred. They do not record or provide access to the actual network payloads. D. Google Cloud Armor provides DDoS mitigation and web application firewall capabilities for internet-facing endpoints, but it does not inspect internal VPC network payloads for anomaly detection. Why are the others incorrect? E. Packet mirroring is a network feature that duplicates traffic. While it enables payload inspection, Cloud IDS is the actual managed product that performs the analysis and detection.
You are migrating your users to Google Cloud. There are cookie replay attacks with Google Web and Google Cloud CLI SDK sessions on endpoint devices. You need to reduce the risk of these threats. What should you do? Choose 2. The options are: Option A, configure Google Session Control to a shorter duration. Option B, set an organizational policy for OAuth 2.0 access token with a shorter duration. Option C, set a re-authentication policy for Google Cloud services to a shorter duration. Option D, configure a third-party identity provider with session management. Option E, enforce security key authentication with 2SV.
To arrive at the correct answer, we focus on the keywords: cookie replay attacks, Google Web, Google Cloud CLI SDK sessions.
The correct answer is option A, configure Google Session Control to a shorter duration.
Why is this correct? A. Configuring a shorter session duration limits the time window during which a stolen session cookie remains valid, directly mitigating the risk of cookie replay attacks. Why are the others incorrect? B. Modifying OAuth 2.0 access token duration does not address the underlying issue of web session cookie lifespans being exploited in replay attacks. C. Re-authentication policies prompt for credentials during specific actions, but configuring overall session control is the primary method to expire stolen cookies. D. A third-party identity provider manages initial authentication but does not control the Google session cookies that are targeted in a replay attack. E. Security keys in 2SV protect against credential theft and phishing during login but cannot prevent the replay of an already authenticated session cookie.
Your development team is launching a new application. The new application has a microservices architecture on compute engine instances and serverless components, including cloud functions. This application will process financial transactions that require temporary, highly sensitive data in memory. You need to secure data in use during computations with a focus on minimizing the risk of unauthorized access to memory for this financial application. What should you do? The options are: Option A, enable confidential VM instances for Compute Engine, and ensure that relevant cloud functions can leverage hardware-based memory isolation. Option B, use data masking and tokenization techniques on sensitive financial data fields throughout the application and the application's data processing workflows. Option C, use the Cloud Data Loss Prevention, Cloud DLP, API to scan and mask sensitive data before feeding the data into any compute environment. Option D, store all sensitive data during processing in cloud storage by using customer-managed encryption keys, CMEK, and set strict bucket-level permissions.
To arrive at the correct answer, we focus on the keywords: compute engine instances, cloud functions, highly sensitive data in memory, secure data in use during computations, unauthorized access to memory.
The correct answer is option A, enable confidential VM instances for Compute Engine, and ensure that relevant cloud functions can leverage hardware-based memory isolation.
Why is this correct? A. Confidential VMs provide hardware-based memory isolation and encryption, specifically securing data in use during computations and preventing unauthorized access to memory. Why are the others incorrect? B. Data masking and tokenization protect data, but do not provide hardware-level memory isolation or encryption to secure data actively in use during computations. C. Cloud DLP is used for identifying and de-identifying sensitive data, but does not secure the actual memory space where data is processed during computations. D. This addresses securing data at rest in cloud storage using CMEK, rather than protecting data in use within memory during active computations.
You plan to synchronize identities to cloud identity from a third-party identity provider, IDP. You discovered that some employees used their corporate email address to set up consumer accounts to access Google services. You need to ensure that the organization has control over the configuration, security, and lifecycle of these consumer accounts. What should you do? Choose 2. The options are Option A, mandate that those corporate employees delete their unmanaged consumer accounts. Option B, reconcile accounts that exist in Cloud Identity but not in the third-party IDP. Option C, evict the unmanaged consumer accounts in the third-party IDP before you sync identities. Option D, use Google Cloud Directory Sync, GCDS, to migrate the unmanaged consumer accounts' emails as user aliases. Option E, use the transfer tool to invite those corporate employees to transfer their unmanaged consumer accounts to the corporate domain.
To arrive at the correct answer, we focus on the keywords, synchronize identities to cloud identity from a third-party identity provider, IDP. Employees used their corporate email address to set up consumer accounts, ensure that the organization has control over the configuration, security, and lifecycle of these consumer accounts.
The correct answer is option B, reconcile accounts that exist in Cloud Identity but not in the third-party IDP.
Why is this correct? B. Reconciling accounts identifies unmanaged profiles in Cloud Identity that do not exist in the third-party IDP, helping administrators secure them. Why are the others incorrect? A. Mandating deletion relies on manual compliance, risks data loss, and does not seamlessly bring the accounts under organizational management. C. Unmanaged consumer accounts exist in Google systems, not in the third-party IDP, making eviction in the IDP ineffective for gaining control. D. Google Cloud Directory Sync, GCDS, syncs directory data but cannot migrate unmanaged consumer accounts or convert their emails into user aliases. E. The transfer tool allows administrators to invite employees to migrate their unmanaged accounts to the corporate domain, gaining full control over them.
Your company is using G Suite and has developed an application meant for internal usage on Google App Engine. You need to make sure that an external user cannot gain access to the application even when an employee's password has been compromised. What should you do? The options are Option A, enforce two-factor authentication in G Suite for all users. Option B, configure Cloud Identity-Aware Proxy for the App Engine application. Option C, provision user passwords using G Suite Password Sync. Option D, configure Cloud VPN between your private network and GCP.
To arrive at the correct answer, we focus on the keywords, internal usage on Google App Engine, external user cannot gain access, password has been compromised.
The correct answer is option B, configure Cloud Identity-Aware Proxy for the App Engine application.
Why is this correct? B. Cloud Identity-Aware Proxy, IAP, establishes a central authorization layer for App Engine apps. It provides context-aware access control, ensuring only authorized internal users on trusted devices or networks can access the app, protecting it even if a password is compromised. Why are the others incorrect? A. While two-factor authentication improves security, it does not provide the application-level, context-aware access control that IAP offers to restrict access specifically to internal contexts. C. G Suite Password Sync is used to synchronize passwords between Microsoft Active Directory and Google Workspace. It does not restrict access to App Engine applications. D. Cloud VPN connects on-premises networks to GCP via IPsec. App Engine runs on Google's public infrastructure, so a VPN alone does not control user access to the App Engine app.
A company has redundant mail servers in different Google Cloud Platform regions and wants to route customers to the nearest mail server based on location. How should the company accomplish this? The options are Option A, configure TCP proxy load balancing as a global load balancing service listening on port 995. Option B, create a network load balancer to listen on TCP port 995 with a forwarding rule to forward traffic based on location. Option C, use cross-region load balancing with an HTTPS load balancer to route traffic to the nearest region. Option D, use Cloud CDN to route the mail traffic to the closest origin mail server based on client IP address.
To arrive at the correct answer, we focus on the keywords,
redundant mail servers in different Google Cloud Platform regions, route customers to the nearest mail server based on location.
The correct answer is option A. Configure TCP proxy load balancing as a global load balancing service listening on port 995.
Why is this correct? A. TCP proxy load balancing is a global load balancing service that handles non-HTTP TCP traffic, such as mail traffic on port 995.
It provides a single global IP address and automatically routes users to the nearest healthy backend instance based on their location.
Why are the others incorrect? B. Network load balancers are regional services, meaning they operate within a single region and cannot globally route traffic across multiple different regions based on the client's location. C. HTTP load balancing is specifically designed for HTTP and HTTPS web traffic, not for general TCP traffic such as email protocols, SMTP, POP3, IMAP. D. Cloud CDN is designed to cache and serve HTTP web content from edge locations. It does not route non-HTTP TCP traffic or support routing to origin servers based solely on client IP for mail services.
Your team needs to obtain a unified log view of all development cloud projects in your CM. The development projects are under the non-prod organization folder with the test and pre-production projects. The development projects share the ABC billing account with the rest of the organization. Which logging export strategy should you use to meet the requirements? The options are option A, 1. Export logs to a cloud pub/subtopic with folders/non-prod parent and include children property set to true in a dedicated CM project. 2. Subscribe CM to the topic. Option B, 1. Create a cloud storage sync with billing accounts/ABC billing parent and include children property set to false in a dedicated CM project. 2. Process cloud storage objects in CM. Option C, 1. Export logs in each dev project to a cloud pub/subtopic in a dedicated CM project. 2. Subscribe CM to the topic. Option D, 1. Create a cloud storage sync with a publicly shared cloud storage bucket in each project. 2. Process cloud storage objects in CM.
To arrive at the correct answer, we focus on the keywords, Unified Log View, All Development Cloud Projects, CM, Non-Prod Organization Folder, ABC Billing Account.
The correct answer is option A, 1. Export logs to a cloud pub/subtopic with folders/non-prod parent and include children property set to true in a dedicated CM project. 2. Subscribe CM to the topic.
Why is this correct? A. Creating an aggregated sync at the folder level, folders/non-prod, with include children set to true efficiently captures logs from all projects within it. Routing to pub/sub allows the CM to consume the unified log stream in real time. Why are the others incorrect? B. Creating a sync at the billing account level captures logs from the entire organization, violating the scope requirement. Additionally, cloud storage is not optimal for real-time CM ingestion compared to pub/sub. C. Creating individual log syncs in each development project creates operational overhead and lacks centralized management. Aggregated syncs at the folder level provide a much better, unified logging strategy. D. Creating individual storage syncs with publicly shared buckets is highly insecure, lacks centralized management, and does not provide real-time log streaming to the CM like pub/sub does.
Your organization has an internet-facing application behind a load balancer. Your regulators require end-to-end encryption of user login credentials. You must implement this requirement. What should you do? The options are, option A, generate a symmetric key with Cloud KMS. Encrypt client-side user credentials by using the symmetric key. Option B, concatenate the credential with a timestamp. Submit the timestamp and hashed value of credentials to the network. Option C, deploy the TLS certificate at Google Cloud Global HTTP's load balancer and submit the user credentials through HTTPs. Option D, generate an asymmetric key with Cloud KMS. Encrypt client-side user credentials using the public key.
To arrive at the correct answer, we focus on the keywords: internet-facing application behind a load balancer, end-to-end encryption, user login credentials.
The correct answer is option C. Deploy the TLS certificate at Google Cloud Global HTTP's load balancer, and submit the user credentials through HTTPs.
Why is this correct? C. Deploying a TLS certificate on an HTTPS load balancer provides transport layer security. This encrypts the connection between the client and the load balancer, fulfilling the requirement for encrypting user login credentials in transit over the Internet. Why are the others incorrect? A. Cloud KMS symmetric keys are for server-side encryption, not client-side. Exposing a symmetric key to the client to encrypt credentials before transmission would compromise the key, violating fundamental security practices. B. Hashing is a one-way function used for verification, not encryption. If you submit a hashed credential, the server cannot decrypt it to obtain the original credential, defeating the purpose of end-to-end encryption. D. While asymmetric encryption can work client-side, using Cloud KMS to manage and distribute public keys to all Internet clients for credential encryption is highly complex, non-standard, and less efficient than simply using industry-standard TLS via HTTPS.
Your organization is implementing separation of duties in a Google Cloud project. A group of developers must deploy new code, but cannot have permission to change network firewall rules. What should you do? The options are: Option A, assign the network administrator IAM role to all developers. Tell developers not to change firewall settings. Option B, use Access Context Manager to create conditions that allow only authorized administrators to change firewall rules based on attributes such as IP address or device security posture. Option C, create and assign 2 custom IAM roles. Assign the deployer role to control compute engine and deployment-related permissions. Assign the network administrator role to manage firewall permissions. Option D, grant the editor IAM role to the developer group. Explicitly negate any firewall modification permissions by using IAM deny policies.
To arrive at the correct answer, we focus on the keywords: separation of duties, deploy new code, cannot have permission to change network firewall rules.
The correct answer is option C. Create and assign 2 custom IAM roles. Assign the deployer role to control compute engine and deployment-related permissions. Assign the network administrator role to manage firewall permissions.
Why is this correct? C. Custom IAM roles implement least privilege and separation of duties by explicitly defining separate permissions for deployments and firewall management, ensuring developers only receive necessary access. Why are the others incorrect? A. Relying on verbal instructions instead of technical IAM controls violates security best practices and fails to enforce separation of duties. B. Access Context Manager controls access based on context, like IP or device posture, but does not replace foundational IAM role assignments for separation of duties. D. Granting broad editor access and using deny policies is complex and violates the principle of least privilege compared to assigning precisely scoped custom roles.
You are managing a Google Cloud environment that is organized into folders that represent different teams. These teams need the flexibility to modify organization policies relevant to their work. You want to grant the teams the necessary permissions while upholding Google-recommended security practices and minimizing administrative complexity. What should you do? The options are: Option A, create a custom IAM role with the organization policy administrator permission and grant the permission to each team's folder. Limit policy modifications based on folder names within the custom roles definition. Option B, assign the organization policy administrator role to a central service account and provide teams with the credentials to use the service account when needed. Option C, create an organization-level tag. Attach the tag to relevant folders. Use an IAM condition to restrict the organization policy administrator role to resources with that tag. Option D, grant each team the organization policy administrator role at the organization level.
To arrive at the correct answer, we focus on the keywords, organized into folders that represent different teams, modify organization policies relevant to their work, upholding Google recommended security practices, and minimizing administrative complexity.
The correct answer is option C, create an organization-level tag. Attach the tag to relevant folders. Use an IAM condition to restrict the organization policy administrator role to resources with that tag.
Why is this correct? C. Tags combined with IAM conditions offer a scalable, secure way to delegate administration. Attaching a tag to folders and conditionally granting the organization policy administrator role limits permissions to tagged resources, adhering to best practices and minimizing complexity. Why are the others incorrect?
A. IAM custom roles cannot dynamically restrict policy modifications based on folder names within the role definition. Scope restriction is achieved via IAM conditions on the role binding, making this approach technically incorrect.
B. Sharing central service account credentials among teams is a security risk. It violates the principle of least privilege, eliminates individual accountability since actions aren't tied to specific users, and complicates credential management.
Why are the others incorrect? D. Granting the organization policy administrator role at the organization level is overly permissive.
It violates the principle of least privilege, enabling teams to alter policies across the entire organization rather than just within their specific folders.
Your organization is implementing a new Python application that will be deployed on Cloud Run. The application needs to connect to a MySQL database that runs on Cloud SQL in a different project in your Google Cloud organization. You must secure the connection from the application to the Cloud SQL instance while minimizing management overhead. What should you do? The options are: Option A, use a public IP address for the Cloud SQL instance. Integrate the Cloud SQL Python connector into your application code to connect to the Cloud SQL instance. Option B, ensure that the Cloud SQL instance doesn't have a public IP address. Configure Cloud Run to use Cloud SQL Auth proxy to connect to the Cloud SQL instance. Option C, ensure that the Cloud SQL instance doesn't have a public IP address. Enforce SSL/TLS. Require the use of a trusted client certificate to connect to the Cloud SQL instance. Option D, ensure that the Cloud SQL instance doesn't have a public IP address. Configure the application's IP address as an authorized network to connect to the Cloud SQL instance.
To arrive at the correct answer, we focus on the keywords, Python application, deployed on Cloud Run, connect to a MySQL database, Cloud SQL, secure the connection, minimizing management overhead.
The correct answer is option B, ensure that the Cloud SQL instance doesn't have a public IP address. Configure Cloud Run to use Cloud SQL Auth proxy to connect to the Cloud SQL instance.
Why is this correct?
B. Removing the public IP address ensures the database is not exposed to the internet.
Configuring Cloud Run to use the Cloud SQL Auth proxy automatically encrypts traffic and uses IAM authentication, securely connecting to the database while minimizing the management overhead of handling credentials and certificates.
Why are the others incorrect?
A. Using a public IP address exposes the Cloud SQL instance to the internet, which increases the attack surface and fails to properly secure the connection. C. Manually managing and rotating SSL/TLS client certificates introduces significant operational complexity, which directly violates the requirement to minimize management overhead. D. Cloud Run services scale dynamically and do not use a single static IP address by default, making it impossible to reliably configure the application's IP as an authorized network.
Your organization is rolling out a new continuous integration and delivery (CI/CD) process to deploy infrastructure and applications in Google Cloud. Many teams will use their own instances of the CI/CD workflow. It will run on Google Kubernetes Engine, GKE. The CI/CD pipelines must be designed to securely access Google Cloud APIs. What should you do? The options are Option A, 1. Create 2 service accounts, one for the infrastructure and one for the application deployment. Point 2. Use workload identities to let the pods run the 2 pipelines and authenticate with the service accounts. Point 3. Run the infrastructure and application pipelines in separate namespaces. Option B, 1. Create a dedicated service account for the CI/CD pipelines. Point 2. Run the deployment pipelines in a dedicated nodes pool in the GKE cluster. Point 3. Use the service account that you created as identity for the nodes in the pool to authenticate to the Google Cloud APIs. Option C, 1. Create individual service accounts for each deployment pipeline. Point 2. Add an identifier for the pipeline in the service account naming convention. Point 3. Ensure each pipeline runs on dedicated pods. Point 4. Use workload identity to map a deployment pipeline pod with a service account. The remaining options are Option D, 1. Create service accounts for each deployment pipeline. Point 2. Generate private keys for the service accounts. Point 3. Securely store the private keys as Kubernetes secrets accessible only by the pods that run the specific deploy pipeline.
To arrive at the correct answer, we focus on the keywords. Many teams will use their own instances of the CI/CD workflow, run on Google Kubernetes Engine, GKE, securely access Google Cloud APIs.
The correct answer is option C, 1. Create individual service accounts for each deployment pipeline. Point 2. Add an identifier for the pipeline in the service account naming convention. Point 3. Ensure each pipeline runs on dedicated pods. Point 4. Use workload identity to map a deployment pipeline pod with a service account. Review the options on screen.
Why is this correct? C. Workload identity is the recommended way to securely access Google Cloud APIs from GKE. Creating individual service accounts per pipeline follows the principle of least privilege, ensuring strong isolation between teams. Why are the others incorrect? A. Creating only 2 service accounts for all teams violates the principle of least privilege, as pipelines from different teams would share the same permissions, creating a large blast radius. B. Assigning a service account to a node pool grants all pods on those nodes the same permissions, violating least privilege and exposing node credentials unnecessarily compared to workload identity. D. Generating and storing static private keys as Kubernetes secrets introduces security risks and key management overhead. Workload identity is preferred as it automatically manages short-lived credentials.
Your company runs a website that will store PII on Google Cloud Platform. To comply with data privacy regulations, this data can only be stored for a specific amount of time and must be fully deleted after this specific period. Data that has not yet reached the time period should not be deleted. You want to automate the process of complying with this regulation. What should you do? The options are Option A, store the data in a single persistent disk and delete the disk at expiration time. Option B, store the data in a single BigQuery table and set the appropriate table expiration time. Option C, store the data in a single cloud storage bucket and configure the bucket's time to live. Option D, store the data in a single Bigtable table and set an expiration time on the column families.
To arrive at the correct answer, we focus on the keywords. Store PII on Google Cloud Platform, stored for a specific amount of time, must be fully deleted after this specific period. Data that has not yet reached the time period should not be deleted. Automate the process.
The correct answer is option C. Store the data in a single cloud storage bucket and configure the bucket's time to live.
Why is this correct? C. Cloud Storage Object Lifecycle Management, time to live, automatically deletes individual objects based on their specific age, ensuring only expired data is deleted while preserving newer data. Why are the others incorrect? A. Deleting a single persistent disk would destroy all stored data simultaneously, including newer data that has not yet reached its expiration time. B. Setting a table expiration time in BigQuery deletes the entire table at once, which would improperly delete data that hasn't yet expired. D. While Bigtable supports garbage collection, cloud storage provides a more direct, appropriate, and cost-effective time-to-live solution for general unstructured PII data.
Your company wants to determine what products they can build to help customers improve their credit scores depending on their age range. To achieve this, you need to join user information in the company's banking app with customers' credit score data received from a third party. While using this raw data will allow you to complete this task, it exposes sensitive data, which could be propagated into new systems. This risk needs to be addressed using de-identification and tokenization with cloud data loss prevention while maintaining the referential integrity across the database. Which cryptographic token format should you use to meet these requirements? The options are Option A, deterministic encryption. Option B, secure, key-based hashes. Option C, format-preserving encryption. Option D, cryptographic hashing.
To arrive at the correct answer, we focus on the keywords: join user information, de-identification and tokenization, maintaining the referential integrity.
The correct answer is option A, deterministic encryption.
Why is this correct? A. Deterministic encryption encrypts a given plaintext to the same ciphertext every time using the same key. This ensures referential integrity is maintained across datasets during joins while securely tokenizing and de-identifying sensitive data. Why are the others incorrect? B. Secure, key-based hashes are irreversible one-way functions. Although they can maintain referential integrity, they cannot be decrypted, making them unsuitable for tokenization where reversible data access may be required. C. Format-preserving encryption maintains data format and referential integrity but is computationally heavier. Since strict format preservation is not required, deterministic encryption is the more efficient and appropriate choice. D. Cryptographic hashing is an irreversible, one-way process. It is vulnerable to brute force attacks and prevents authorized users from reversing the tokenization, failing the requirement for a secure tokenization format.